Hi everyone, so today we're going to be doing more notes on factoring. So today we're going to be getting into the sum and difference of cubes and factoring by grouping. So go ahead and pause this, write all of this stuff down, and then push play when you're ready. All right, so the steps for the sum and difference of cubes is, first and foremost, this is what we do with all factoring, is to always factor out any common term. So if there is a GCF, always factor out the GCF first. Step 2 is to identify your A and B values. And then step 3 is to use your formula. And then the final step is always to double check, make sure nothing factors any further. So here's the formula for the sum of cubes. So notice sum is addition, and then cubes, these are both perfect cubes. So A cubed plus B cubed. Now the formula for this is A plus B in parentheses, and then A squared minus AB plus B squared. Now the important part that I like to stress about this is the same, different, same. So for both of these formulas, sum and difference, it's exactly the same. It's an A and a B in parentheses, and then A squared, AB, and B squared. So what I do when I'm writing these formulas is I just write out the AB, A squared, AB, B squared, and then I go back and just do same, different, same. So we're talking about the, oh my gosh, addition sign. Wow, that took me way too long to remember what that was called. So the addition sign here, addition means that same will be addition, different will be subtraction, same will be addition. And you'll see when we do the difference of squares that it follows the exact same pattern. If you're curious why this works, multiply this thing out. So multiply it all out, distribute everything, and you end up with this because all sorts of stuff cancels out. Basically everything cancels out except the A cubed plus B cubed. Anyways, let's look at some actual examples. So the first one we're going to look at is x cubed plus 8. So first and foremost, is there a GCF? Good, you should have said no, because there's no like terms. So let's identify our A and B values. So this is a cubed term plus a cubed term. So x cubed is x to the power of 3, and 8 is 2 to the power of 3, because 2 times 2 times 2 is 8, which means this is the A value, this is the B value. So when we write out our answer, we are literally just filling stuff in. So I'm going to show you what I mean by the just fill in the A's and B's, and then the signs will get filled in afterward. So I'm going to have x and 2, and then I'm going to have x squared, 2 times x, because that's the A and B, and then B squared, so 2 squared, which is 4. So I write that out. Now I'm going to fill in my signs. So same, oops, sorry, so it's, yeah, same, so plus, different, minus, same, plus. Now we need to ask ourselves if this factors any further. Can't do anything with the x plus 2. And if I look at this, if I tried doing the big X, nothing factors any further. So we're done. This is our answer. Let's look at another example. So I'm going to make a little side note. I didn't leave room for it on my actual piece of paper that I'm writing stuff out, but I want to just make a little side note, and you can make a list too and keep it handy if you'd like. So 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And then you can keep going. So this is really helpful to have on hand. The numbers that I give you on these problems aren't going to be like insanely big. They will be reasonable numbers because I don't expect you to, I don't know, I'm not going to make you do really big numbers. So if you have just a general idea, maybe go up to like 6 cubed and just have that off to the side. But these should be ones that you should be able to recognize are perfect cubes. So with that in mind, let's look at the second example. So first, is there a GCF? You should have said no. There is not. So when I look at this, 27x cubed. So 27 will be 3 cubed, and then x cubed will just be x. Now, a way that you can figure this out on a calculator too, I'll show you just in case you're kind of stuck and need to figure out whether or not it is a perfect cube. If you're using a scientific calculator, I'll show you that in a second. But so on your calculator, you have buttons that are, where is it? I did this last time too. I should have found the button before I did this. I'm going to pause this. Hang on. Okay, I found it. I just realized I didn't need to tell you I was pausing because my screencast if I pause. Anyways, so if you're using a graphing calculator, you most likely have a button that's called Math. So if you click Math, then these options show up. And there is option number 4 on my calculator is the cube root. So I can click option 4. And if I want to check if 27 is a cube root, I type in 27, enter. So 3 cubed equals 27. Now, if you have a scientific calculator, that's this kind. So on this calculator, you have a button. It's on your little up arrow caret. If you have a different model of scientific calculator, it might be somewhere different, but it's the up arrow. My color is green, so it's a little tiny X with the radical. So that means you're going to use the second button. So if I'm finding the cube root, I will type in 3 and then second and that button. And notice how now it says 3 and then X rad. And then I'm going to type in 27 equals 3, which means the cube root of 27 is 3. Or in other words, 3 cubed is 27. So that's how you can figure it out on your calculator. But again, I'm going to be giving you pretty small numbers. And you can keep your little cheat sheet handy. All right, 125 is 5 cubed. So 3x is my a value. 5 is the b. So now I can plug these into my formula. Now this one, because my a value is 2 terms, I want to be careful with that when I write it out. So I'm going to have a and b, and then I'm going to have a squared, so 3x squared, and then I'm going to have a times b, so 3x times 5, and then I'm going to have b squared. So if you want to write 5 squared or if you want to just go to write 25, doesn't matter. 5 squared, close the parentheses. Now my pluses and minuses. This is plus, so it's going to be same, different, same. So now when I simplify this, the 3x plus 5 stays the same. 3x squared, or 3x quantity squared, I should say, is 9x squared minus 15x plus 25. And then I'm going to save you the work, but if you were to check this to see if it factors further, you would get that it does not. The big X does not give you any possible answers that will work. All right, looking at another example. First question we always ask ourselves, is there a GCF? You should have said yes. And our GCF is 2x. So I need to factor out the 2x. And then I'll be left with 8x cubed plus 1. Now I know that 8 is a perfect cube and so is 1. So I have my a and b. Oops. Oh, it's supposed to be an arrow. Pretend like I didn't underline that. So this will be 2x quantity cubed and then 1 cubed. So my a is 2x and my B is 1. I want you to go ahead and pause and try to finish this problem on your own, and then push play when you're ready to check. And while you're doing that, you can look at my cute little bunny pen. Go ahead and check your answer, and make sure that you remember to write that GCF out in front. Now, another thing I want to mention, I choose to write out the A's and B's first and then fill in the signs. Some people feel comfortable doing it all at one time. Some people feel comfortable just writing 4x squared instead of 2x quantity squared. It's totally personal preference. The only thing I will caution you on is if you're doing something where I'm grading your scratch work and you go straight to the final answer and it's wrong, I cannot give you partial credit if there's no work shown because I can't see where your mistake was made. So that's the only thing that I'm going to caution you about. And I also definitely recommend showing this step at the very least when you start doing these problems, just to kind of get the hang of the formula and how to do it, etc., and make sure that you're not making mistakes. Now we're going to move on to the difference of cubes. This formula should look oddly familiar because it is exactly the same formula, except now your signs are switched. The formulas are identical except for the pluses and minuses, which is really nice. So this one is minus, and again, we still follow the same, different, same. So since it's minus, the sames will be minuses, and then the different will be plus. All right, I want you to go ahead and pause this video, try the first example on your own, and push play when you're ready to check. All right, I've now corrected the part in the notes that I mentioned when you first wrote down this formula, that I told you I would address it in a few minutes. So this should say plus. So when you did this formula, it should be same, different, plus. So no matter what, your last sign is always plus. So this one, actually, I'll make it a little bit easier for you to remember this. I'm going to change this to also say plus. It is same, different, same. But I'm going to change it just for consistency purposes. I'm going to change this to also say plus. Sorry about that. So change that to also say plus. So we'll just do that to keep it consistent. So same, different, plus. Same, different, plus. Please, please, please make sure that you fix that. All right, so this is the answer that you should have gotten for this example. Go ahead and check it. Let's look at another example. So we have a perfect cube minus a perfect cube. What is the cube root of 125x cubed? Good, you should have said 5x. And then what is the cube root of 8? You should have said 2. Which means this is A and this is B. So I want you to go ahead and push pause, finish this on your own, and remember, same, different, plus. So finish this problem and then push play when you're ready to check your answer. Let's do one more example with the difference of cubes. So when you look at this last problem, you should notice that they have an x in common, so we know we're going to have a GCF, but you should also notice that 128 and 16 are not perfect cubes, which means there's some number in common as well. So when you look at this, you may notice right away that they're both divisible by 16, and that's what's going to get pulled out. But if you don't, I'm going to show you how to figure it out. So we know that these are both even, which means 2 goes into them. So 128 divided by 2 is 64, which is a perfect cube. And 16 divided by 2 is 8, which is also a perfect cube. But does 64 and 8 also have something in common that goes into them? You should have said yes. 8 still goes into both of these. So since 8 goes into both of those, and 2 goes into both, I'm going to see if they're both divisible by 16. So 128 divided by 16 goes in 8 times, which is a perfect cube. And 16 divided by 16 is just 1. So 8 and 1 are perfect cubes. Once you do more of these examples, you'll kind of start getting the hang of it and be able to recognize GCFs and factors a little bit easier. But if you struggle with it, that's definitely a helpful method to figure out what they factor by. So 16x is going to get factored out, and then 8x cubed minus 1. So I want you to go ahead and finish this problem on your own. Push pause, and then when you're ready to check, push play. Go ahead and check your answer, and make sure that you remembered to write your GCF on the outside of the parentheses, on the outside of the whole thing. And this trinomial does not factor any further, so we're done. Now we're going to look at our last form of factoring, which is called factoring by grouping. And this is typically when you have 4 terms. So we've looked at trinomials using the big X. We've looked at 2 terms when it's sum and difference of cubes or difference of squares. Now we're looking at 4 terms, or it can actually be even. It can be 6 terms, it can be 8 terms, but I'm only going to be giving you examples that are 4 terms. So go ahead and pause and write this all down, and then we'll go over a few examples. All right, so our steps for solving this. Rewrite your expression in standard form if needed. So if it's not in order from highest to lowest exponent, rewrite it. That is critical that you do that. Then factor out a GCF if it has one. Again, that's always something that you need to check before you factor. Always, always, always see if there's a GCF. Then we get into the actual factoring by grouping. So you're going to find the GCF of the first 2 terms, the last 2 terms, and then group them together. I'll explain to you what that means when we do an example. And then lastly, same as always, check to see if it factors any further. So let's look at our first example. Is it written in standard form right now? You should have said no. This x squared is at the end, and it shouldn't be. It should be between the x cubed and the x term. So let's go ahead and rewrite this. So it's going to be x cubed minus 7x squared plus 3x minus 21. So now that it's written in standard form, I want to look at my first 2 terms. And my GCF of those first 2 terms is x squared. And what I'm left with will be x minus 7. And then I'm going to look at my last 2 terms. Notice that I group that plus in with the 3x because 3x is positive. So my GCF is positive 3. Notice I put a plus. So positive 3. And then x minus 7. Now, this is the fun part. Well, I think it's fun. When you write the answer, you are getting your answer from this stuff that you wrote out. So I want to point out x minus 7 and x minus 7 in parentheses. They are the same. This is on purpose. These always have to be the same. If it's not, if you don't have the same thing in here, you need to double check if you wrote it in standard form and if you factored out the GCFs correctly. These will always, always, always be the same. Put a little bubble around this too to really reinforce that. And then that gives us one of our factors. And then the other one comes from our GCFs that were factored out. So one of my factors will be the x squared plus 3. And then the thing that's underlined in pink, the x minus 7, is our other one. Now, the most common question that gets asked is, well, if x minus 7 is written twice, why don't we write it twice in the answer? And the reason for that is because if we were to multiply these together, x squared times x gives us x cubed, which is what the highest power is. If we had another x plus 7 in here, it would raise it to x to the 4th, which is incorrect. If you want to understand where this particular thing comes from, why it works, you can set up office hours or come see me. This actually comes from using the box method, gives you a really good explanation of why those numbers are there and why it works and why you only write it once. Next example, is it in standard form? You should have said yes. They are in order from highest to lowest power. So I'm going to check my first two terms. What's my GCF? You should have said x cubed. And then it leaves us with x minus 3. And then I'm going to look at my last two terms, include that positive in front of the 8x. And what's my GCF? You should have said 8, positive 8. So we'll be left with x minus 3. I'll double check. The things that are in your parentheses are the same, so we're in good shape. And then we have the x cubed and the positive 8. So when I write this out, x cubed plus 8 times x minus 3. And then our final step, does it factor any further? You should have said yes. X cubed plus 8, that's what we just covered. This is a sum of cubes, sum of perfect cubes. So the x plus 8 can be factored even further. So this guy, since we just went over this, I'm not going to show all the steps for it. I'm just going to write that this is the sum of cubes and factor it. Oops, dropping pens. So my final answer, when I write this out, it's going to be the x and the 2, and then x squared, 2x, and then 4. And it's same, different, positive. And then our last factor, x minus 3, that carries down. Now we are done. Nothing else factors. Do you think it matters what order these are written in? You should have said no, it doesn't. They're all multiplication, and multiplication is commutative, which basically just means you can switch the order and it'll still be the same. But for the sake of checking answers and making it easier, I'm going to keep mine written in this order. Because this first parentheses factored to that, so it makes sense logically to keep it as the first two terms written. If you don't want to do that, that's fine, but that's how I'm going to keep my stuff organized for homework and such. Last example of the day. First thing we ask, is there a GCF? You should have said yes. The GCF is 2x. The dead giveaway that there's a GCF is that every term has an x. And they're also all even, which means 2 is going to go into it. So this is going to be 2x and then parentheses, x cubed minus 3x squared minus 16x plus 48. So that GCF is just going to stay hanging out in front. And we're looking at what's inside here. So my first two terms, what's my GCF? We should have said x squared. And then I'm left with x minus 3. And then my last two terms, what's my GCF? You should have said negative 16. That's a super, super common mistake. But whenever this third term, so basically your last two terms, when the first one is negative, you absolutely always have to factor out that negative, always. So same as with trinomials, when your negative is the first thing, or your first sign is negative, it has to get factored out. And then we're left with x minus 3. Also, if you didn't factor out the negative, this would have been x plus 3, and they would not be matching. So that would also be a giveaway that you made a mistake with the factoring. So my things in the parentheses match. And then my terms, the GCFs, are the other one. So 2x stays out in front. And then x squared minus 16, x minus 3. Does this factor any further? You should have said yes. X squared minus 16 is a difference of squares. Difference of squares, factor it. So my final answer, I'm going to bring it up here, 2x still stays out in front. My difference of squares is x plus 4, x minus 4, and then we have the x minus 3. And there we go. That is the end of our notes. Have a good rest of your day.